Hello everyone, this is Chemistry and Glance and my name is Annette. In today's video, we're going to do our last minute revision on calculating the reacting masses. So now that we know this equation, this is an equation that's very useful in your exam. It comes up very often, but you need to know it off by heart. It's not going to be given to you in your data booklet. But as long as you know this equation, you can do many things with it. For example, let's imagine you're given an equation of magnesium reacting with oxygen and you get a magnesium oxide. You are told that we have oxygen in excess. So we don't know the mass, you know there's enough oxygen to react with magnesium because there's a lot of it. You're also told that you're using 1.215 grams of magnesium. And now you need to calculate grams of magnesium oxide that's going to be formed. In order to work this out, you need to find some kind of a ratio between magnesium and magnesium oxide. We're only looking at those two because oxygen is in excess. So there's going to be definitely enough oxygen in the reaction. So we don't take this into consideration. We're only looking at these two. So our ratio is going to be that little n. I'll show you how. So our little n, mass over mR. We know the mass, we can work out the mR. So n equals mass over mR, which is equal to 1.215 divided by 24.3. Don't worry about that big 2. We're just looking at the mR of magnesium, which is its atomic mass. What you get is 0.050 mole. And now we can use this moles in order to find this mass using this equation. However, before you do this, you need to realize that there are numbers in front of them. In this example, we have 2 to 2. So, however many magnesiums we use here, we make this many magnesium oxides in the product side. So, because they're equal, we can use exactly the same moles. However, this time we're trying to find the grams of this. So we have to rearrange this equation. So mR is divided here, so it goes over to be times. Our n is exactly the same as for magnesium. Multiply it by the mR. So mR of magnesium oxide is 24.3 plus 16 for oxygens, which gives us 40.3. And our final answer is 2.015 grams. What I'm saying, this is very important because if we had a completely different equation and let's say this would be 1, so no number at all, and this is 2, our ratio would change to 1 to 2. 1 magnesium used, 2 magnesium oxides formed. If it's 1 to 2 ratio and the number of moles of our magnesium was 0.050 moles, it was for just 1 magnesium. But now we have 2, so what you'd have to do is multiply the number of moles first before you could carry on with finding the mass. You always have to look at the ratio because that's the easiest mistake you can make, not looking at the ratio. If you had 1 to 2 ratio, number of moles would be for 1, not for 2. So you have to multiply it by 2 first and then use this moles instead of this to find your mass. I really hope that makes sense.